So good morning students. Let us discuss about today's class. So yesterday we discussed about concentration terms. Now we discuss about molality. 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 So what is molality? The moles number of moles of solute present in present in 1 kilogram 1 kilogram of a solvent 1 kilogram of a solvent is called as molality. So molality, small m is equal to n number of moles present in kilogram. Here v can be replaced with w. Okay, capital W you will write n by capital W in kilograms. So another, if mass is given in grams, then the formula will become n means number of moles. Number of moles means mass by molar mass into 1000 by W 1000 by capital W in grams. This is the formula to calculate molality. And units, what are the units? Moles per kilogram or molal. We can write it as molal. Okay, effect of temperature, it is independent because mass is used here, so it is independent of temperature. It is independent of temperature. Okay, so this is which one? Molality. Okay, next, normality. What is normality? So normality means it is denoted by capital M. Normality, it is denoted by capital N. Normality. What is normality? The number of gram equivalent weight. Number of gram equivalent weights. Number of gram equivalent weight dissolved in 1 liter solution is called as normality. Okay, so normality can be calculated by G by GEW into 1000 by V in milliliters. Normality G by GW into 1000 by V in milliliters. So what is GW? GW means gram equivalent weight. GW means gram equivalent weight. GW means gram equivalent weight. So for acid, how we calculate gram equivalent weight? For acids, gram equivalent weight is equal to molar mass by basicity of acid. Molar mass upon basicity of acid. So basicity of acid means, for example, HCl is there. Basicity how much? Basicity how much? 1. For HCl, basicity how much? 1. For H2SO4, basicity equal to 2. Okay. For H3, CH3COOH, basicity equal to how much? 1. For H3PO4, basicity equal to how much? 3. This hydrogen we have to. The hydrogen which can be replaced by metal ion. Okay, those hydrogens we consider here. So this hydrogen get replaced here. That's why we here the basicity of acetic acid how much? 1. Here all the 3 hydrogen get replaced with metal ion. So the basicity is how much? 3. Okay. Next. For base, gram equivalent weight is equal to molar mass of acid. Here molar mass of base upon acidity of base. Our example, suppose NaOH is given. Basicity equal to 1. NaOH is given, basicity equal to how much? 1. If KOH is given, basicity how much? 1. Okay. If suppose magnesium hydroxide is given, basicity equal to how much? 2. Aluminium hydroxide is given, basicity equal to how much? 3. Okay. So this is how we calculate basicity for base equivalent weight. Okay. For salt, so gram equivalent weight is equal to molar mass of base, molar mass of salt upon number of positive molar mass number of positive or negative charges, because in salt number of cations is equal to number of anions. Positive charges and negative charges both remain same. Okay. If suppose in case of KCl, potassium chloride is given. In case of KCl, number of cations, how many cations? KCl will divide it into K plus, it will ionize to give K plus and Cl minus. So how many positive charges? 1 positive charge, 1 negative charge. Okay. If suppose K2SO4 is given, 2K plus SO4 minus 2. So 1 positive, 2 positive charges, 2 negative charges. So n factor will be how much here? Here we will take 1. Here we have to take 2. Okay, like this. Okay. For oxidant and reductant, for oxidant or reductant, gram equivalent weight is equal to molar mass upon number of electrons exchanged in the reaction. Number of electron exchanged in the reaction. If suppose KMnO4 is there, it will ionize to give K plus and MnO4 minus. So this MnO4 minus, if reaction is carried out in acidic medium, MnO4 minus is converted to which one? Mn plus 2. Okay, so here oxidation state of manganese is how much? Here before the reaction oxidation state is how much? Plus 7. So here reaction completed, oxidation state is plus 2, means how many electrons exchanged here? 5 electrons exchanged here. So therefore molar, how we calculate gram equivalent weight? Gram equivalent weight is equal to equivalent weight is equal to molar mass of potassium permanganate is 158. So 158 divided by how many electrons exchanged here? 5 electrons. So how much here? This will be nearly 31 point something, 31.0 something. So this is how we calculate gram equivalent weight of acids, bases, salts and oxidant reductant. Okay, so gram equivalents, number of gram equivalents is equal to number of gram equivalents. How we calculate number of gram equivalents? Can be calculated by number, under formula, number of moles into n factor. Number of gram equivalents formula is number of moles into n factor. N factor means here, if suppose acid is given, acid's basicity. In case of acids, n factor is taken as, for acids, acid's basicity. For base, acidity of base. For salt, number of positive charges or number of negative charges. For oxidant or reductant, the number of electrons exchanged in the reaction. So this is how we calculate n factor. Okay, so here very important point here, what is the relation between molarity and normality? Normality is equal to molarity into n factor. This is the relation between normality and molarity. So if molarity is given, by using n factor, we can find out normality. So normality is equal to molarity into n factor. Okay, so this what are the units? What are the units here? Units are equivalents, equivalent per liter, equivalents per liter, equivalent per liter. Okay, this is the unit. Okay, and it is volume is we are using volume, 1 liter solution. So in that case here it is dependent on temperature, Okay, so these are concentration terms. Okay, so these are all about which one? Concentration terms. Now we move to solubility. So what is solubility? Solubility means maximum amount of solute that can be dissolved in specified amount of solvent at constant temperature is called as solubility. Now in this chapter we discuss about solubility of solid in liquid, solubility of gas in liquid, solubility of liquid in liquid. We discuss about 3 things. Solubility. So what is solubility? Maximum amount of solute that can be dissolved in, that can be dissolved in specific amount of solvent, specific amount of solvent at constant temperature. Okay, now effect. So here what are the factors which affect the solubility? One is nature of solute, second one nature of solvent, third one temperature, fourth one pressure. Okay, so to explain the effect of pressure we have Henry's law. So Henry's law, what is Henry's law? P is equal to, solubility is directly proportional to. So here solubility is given, we express solubility by using mole fraction. So to measure or to express solubility, we use which one? Mole fraction. The solubility is directly proportional to, solubility of gas is directly proportional to its pressure present at the surface of liquid. For example, this is the liquid. Liquid is given here. Liquid is given here. So we dissolved gas in liquid. Gas is allowed to dissolve in liquid. Now what happens? Gas will pressure some, gas will apply or exert some pressure on the surface of liquid. So as the pressure increases, the solubility of gas increases. So that is given in the form of law, that is Henry's law. Pressure means whatever pressure is exerted by gas, here pressure exerted by gas is directly proportional to solubility. Means pressure exerted by gas is directly proportional to mole fraction. So here P is equal to KH into XA. P is equal to KH into XA. So KH is equal to, from this KH is equal to P by XA. P by XA. Means here Henry's law constant is, Henry's law constant KH means what here? Henry's law constant. KH is equal to what is this? Henry's law constant. Henry's law constant. KH is equal to Henry's law constant. It is not universal constant. It varies with temperature. KH is directly proportional to temperature. Means temperature increases, Henry's law constant also increases. Here, what is P here? What is P? P and X. P means here, P means partial pressure of gas. Partial pressure of gas. Partial pressure of gas present at the surface of liquid. Surface of liquid. Okay. Now X is equal to, what is X here? X means X is equal to mole fraction of gas. Mole fraction of gas. Mole fraction of gas. Okay. So here if we observe these two, the relation is the KH, Henry's law constant, is inversely proportional to mole fraction. Means if KH value increases, mole fraction value decreases. Mole fraction in the sense solubility decreases. As the Henry's law constant value increases, solubility what happens? Decreases. Okay. So this is the relation between solubility and mole fraction. Okay. So as the pressure increases, solubility increases. As the Henry's law constant value increases, solubility what happens? Decreases. Okay. So this is Henry's law. Now Raoult's law. Raoult's law. Raoult's law. So Raoult's law is, it explain about vapor pressure. It explain about which one? Vapor pressure. What is vapor pressure? Vapor pressure means, so before going into Raoult's law, we discuss about vapor pressure. Vapor pressure means, suppose this is the liquid. Suppose if we have taken, this is one container is there, liquid is present here. Okay, liquid is there. We closed this vessel with one container. Closed this vessel with this container. Okay, this is the container. Now what happens? This liquid get evaporated. So whatever the liquid molecules are there, some of the liquid molecules which don't have balanced attraction forces, they get evaporated. Okay, this is the surface of liquid. Surface of liquid. Okay, some of the molecules which are present at the surface, they experience only attraction forces from downside direction. Here on the surface, there is no attraction force. In that case, what happens? The liquid molecule will escape into the space. So this is called as vaporization. So this vaporization take place here. After some time, what happens? The vapor molecules which are come in contact with this liquid surface, they get attracted by the liquid. Now what happens? Liquid molecule converted into vapor molecule converted into liquid. So two processes take place here. One is liquid is converting into vapor. Another one is vapor is converted into liquid. Vaporization, at the same time liquidization. Now what happens here, after some time equilibrium is established between liquidization, rate of vaporization becomes equal with the rate of liquidization. In that case what happens, whatever vapor is present at the surface of liquid, this will exert some pressure on the surface of liquid. The vapor which is in equilibrium with the liquid surface, it will exert some pressure on the surface of liquid. This pressure is called as vapor pressure. This pressure is called as vapor pressure. This pressure is called as vapor pressure. So vapor pressure means pressure exerted by the vapor, gaseous vapor, which is present at the surface of liquid. This pressure is called as vapor pressure. Now Raoult's law. So Raoult's law explain about vapor pressure. It explain about vapor pressure in non-volatile solute. Non-volatile solute in volatile solvent. Non-volatile solute in volatile solvent. So what is non-volatile? What is volatile? Volatile means which easily get evaporated. Non-volatile means which does not get evaporated easily. So volatile means petrol, diesel, kerosene, ether. These are all volatile solvents. Non-volatile means sugar we can take, water we can take. Okay, non-volatile solutes. Now when we dissolve non-volatile solute in volatile solvent, in that case what happens? The decrease in vapor pressure, P naught minus Ps by P naught, becomes equal to the mole fraction of solute. Becomes equal with the mole fraction of solute. This is called as which law? Raoult's law. In case of non-volatile solute in volatile solvent. Here P naught means, what is P naught? What is Ps? We will see here. P naught means what here? P naught means vapor pressure. Vapor pressure of pure solvent. Vapor pressure of pure solvent. Ps means vapor pressure of solution. Vapor pressure of solution. Okay, here x2 means mole fraction. x2 means mole fraction of solute. Mole fraction of solute. Which solute? Non-volatile solute. Mole fraction of non-volatile solute. Mole fraction of non-volatile solute. Okay, so here x2 can be calculated. X2 means mole fraction. So how we calculate mole fraction? As I said in the last class, mole fraction can be calculated by number of moles of component by total number of moles. We are calculating the mole fraction of solute. In this case, the formula will be x2 is equal to n2 by n1 plus n2. Here n2 means, what is n1, what is n2? N1 means number of moles of solvent. Number of moles of solvent. N2 means number of moles of solute. Number of moles of solute. N1 means number of moles of solvent. N2 means number of moles of solute. Okay, N2 and N1. Okay, N1 means number of moles of solvent. N2 means number of moles of solute. Okay, this is how we calculate mole fraction. So this is the Raoult's law in case of non-volatile solute present in volatile solvent. This is the Raoult law in case of non-volatile solute in volatile solvent. Now Raoult's law in case of volatile solute present in volatile solute present in volatile solute present in volatile solvent. Volatile solute present in volatile solvent. Here the partial vapor pressure is equal to partial vapor pressure. P means partial vapor pressure is equal to vapor pressure in PA. PA is equal to P naught A into XA. P P naught A into XA. So what is PA, what is P naught A, what is XA? PA means partial vapor pressure. PA means partial vapor pressure. Partial vapor pressure of component. Of component. Okay. P naught A. What is P naught A? P naught A means partial vapor pressure. Partial vapor pressure. Partial vapor pressure of component in pure state. Pure state. Pure state. Okay. Next. What is XA? Mole fraction. Mole fraction. Mole fraction of component. Mole fraction of component in liquid state. Mole fraction of component in liquid state. So PA is equal to P naught A into XA. If suppose B component is present, then PB is equal to P naught B into XB. Okay. Now total pressure is given by PA plus PB. Total pressure is given by PA plus PB. So total pressure, PA means what is the value of PA? P naught A into XA. PB means P naught B into XB. So this will give total pressure. Total pressure. Okay. So here this one is there. Another method is also the other one. If suppose PA is given, PA is equal to XA into PA is equal to total pressure into YA. Here XA means what? Mole fraction of component in which state? Liquid state. Here YA means mole fraction of component. Mole fraction of component. Mole fraction of component. Mole fraction of component in vapor state. Mole fraction of component in vapor state. Mole fraction of component in vapor state. Okay. So here now it will become, so PA is called, we know PA. PA means what? P naught A into XA is equal to total pressure into YA. At the same time, PB is equal to, what is PB? P naught B XB is equal to total pressure into YB. So this is also important formulas. YB means what here? YB means mole fraction of component in vapor state. Mole fraction of component B. Here YA means mole fraction of component A in vapor state. Mole fraction of component B. Mole fraction of component B in vapor state. So this is how we calculate partial vapor pressure of components A and B. If mole fraction is given, we will use these formulas. Okay. So the solutions which obey Raoult's law, is called as ideal solution. The solution which obey Raoult's law is called as ideal solution. Which not obey is called as non-ideal solution. Which does not obey Raoult's law are called as non-ideal solutions. Okay, so this is up to today's class. So in next class we will discuss about differences between ideal and non-ideal solutions and colligative properties. Okay, thank you.